Good evening. How is everybody? Thank you all for coming. I wanted to get this started. I wanted to thank Park for the wonderful facility, and wanted to welcome everybody to the first 2012 MIT Club of Northern California Energy and Clean Tech event. My name's Steve Jordan. I've been one of the volunteers for several years, and wanted to kick this off. As you know, we've had a very active last couple of years in energy and clean tech. I want to thank, in fact, Doug Sprang for being in the inspiration for all of this. Doug, take a bow. Thank you. We've had many events here. A lot of them have been faculty members from MIT, as you know, and most of them are doing groundbreaking work in the energy field. And tonight's a little bit different. We have a speaker who also has contributed significantly to the energy field over the last 8 or 10 years or more. I've known him, Kevin Surace, the CEO of Sirius Energy, for about 12 years, I think, going back to General Magic, as I recall. So some of you may remember General Magic, quite different business from energy. But I remember one story in the mid-2000s. He told me he was going to take over a company that made soundproofing for cars. And as it turns out, that soundproofing for cars is what led him to where he is today. I won't spoil the details because I think he'll do a much better job of telling you that. But in the process of going from soundproofing for cars to energy conservation, he's built one of the leading energy conservation companies in the country. He was named Entrepreneur of the Year in 2009 by Inc. magazine. And he was also featured as a centerpiece of the Obama administration's activities in energy in 2009. He has many interests in clean energy. He's the chairman of Zeta Communities, which builds net zero energy buildings, modular buildings in Sacramento in a factory. And he's also chairman of Array Power, which has an inverterless solar array system, basically. But outside of the energy field, he serves as the director of music in the Bay Area, in Silicon Valley, in particular at the St. Lawrence Academy, where he leads annual performances that they put on in conjunction with the rest of the school. And in 2009, the White House had asked him to attend an event where he would be recognized for contributions that I think we'll probably hear about tonight. Unfortunately, he had to decline because he had the musical to conduct. I think that occurs in March of every year. So we're fortunate that this year we got him before the musical so that he's able to come and speak to us. Please join me in welcoming Kevin Surace.
Thank you, Steve, for that wonderful introduction. Let's see if we can switch to the other Mac computer here. Look at that, it actually worked. You never know. Interestingly enough, you'll appreciate this. This is going to be a 16 by 9 screen. It took about a half an hour to get the darn thing to work, actually, at 16 by 9. And we ended up, for those who want to know, at a 90 hertz refresh rate, which was very unusual for a projector of this type. That's got to turn on someone here. Come on, that's really geeky stuff. So, rethinking an industry, 9 things we did. We probably did 900 things, but I wanted to think about some of the things that we did that were really, really different and interesting, and something that you can take with you. Even if you take half of one of these things, you'll go, that's kind of interesting. Maybe I can use that in my business or my life or something else. You'll also see some of the things we did that were terribly gone awry, probably. So I've got to give you a little background on the company at first. So Sirius Energy, we convert energy spend to real estate value. Energy spend to real estate value. Well, how do you do that? Well, let's think about this. You know, we have all grown up in an era, and us and our fathers before us and parents before that, and grandparents, and where, you know, there's a utility bill at home and there's a utility bill for this building, and we just take that as some of the cost of being alive. It's just a utility bill. By the way, there was a time in this country you didn't get a utility bill. There was a time on Earth where humans didn't get a utility bill. In fact, it's the majority of time on Earth we did not get utility bills. But somehow now, not only, by the way, do we get utility bills, we get cable bills at $300. Does anyone else get that? How did cable, it's not worth $300. I know that's derivating from the topic here, but it just seems that there's a problem. So it's not clear that our energy is what we're spending either, let alone the sustainability and the green impacts and the impacts to the environment, et cetera. I mean, why are we spending sometimes hundreds or thousands of dollars a month at home, and in a building, you know, like this, it may be $1 or $2 or $3 or $4 or $5 a square foot to heat and cool and light and everything else, and we've just taken that's a given. Well, why is that a given? Well, it's primarily a given because nobody's bothered to look at that line item and say, how would one reduce it, and how would one reduce it dramatically with technology that we should be inventing here in Silicon Valley or wherever. And so that's what we're really doing, because if we can reduce the energy spend of a building like this, what happens? If we reduce the energy spend, the real estate value goes up because your operational costs went down. It's really simple. So that's how you convert energy spend, which is completely stupid, it's waste of your money, into real estate value. And that's what we do. We are a tech company. We're in Silicon Valley. The whole thing is Silicon Valley. 52 patents issued or pending. By the way, I used to not put this in there. I really just added this in the last couple of months. You might know why, because everybody says, you didn't take any DOE money, did you? Do you know that before Solyndra, the failure of Solyndra, before that, people said, how much DOE and government money did you get? Because that was an indication of how much you were worth and how good you were as a company. And then the day that thing failed and people were drug in front of Congress, it's like, you didn't take any DOE money. By the way, it's the same people asking the same question. I don't understand. Mostly VCs, but we're not going to talk about that. Attacking the largest energy spend category. Believe it or not, more energy spend occurs in the built environment than anywhere else. People think it's cars and this and that. I'm going to show you that. We happen to have somehow built a brand that's the category leader. We're the guys. Now, that's an honor to be that, but it also means that we've got to keep moving and we've got to really keep the process going and keep inventing. So we're going to talk about that. So when you look at energy spend, don't you love this slide? When you look at energy spend, you can't do this in PowerPoint. Building operations is 40%, building materials 12% to make building materials every year. Basically, 52% of the entire energy pie is spent somewhere around the built environment. And cars are only 9%. By the way, cars are big. It's just buildings are way bigger. It's really, really interesting. Lighting, heating, cooling our buildings. And if you can address those problems in buildings, you get smarter buildings that save energy and save money, but you improve occupant comfort, improve productivity, and increase the property value all at the same time. And this turns out to be really important. The people impacts are really, really critical. Now, why are they critical? There is this sort of notion of times 10, and I'm just going to give you really, really quickly. So if your energy spend is, call it $3 a square foot, your rent in a building might be $30 a square foot. The spend on your people could be $300 a square foot, and the products they produce are worth $3,000 a square foot. So in fact, what you really want to do is swing those things to the right by saving money on the left. You don't just want to swing the thing on the left. And I think people haven't realized that. So we really want to make people more productive and more comfortable and more useful in the buildings and make the buildings more valuable. That's how we're going to move this industry forward on the energy efficiency side. How big is this market? Well, we're targeting 20 to 50% energy spend savings in the buildings that we're involved in, and I'll talk about the things that we do. Homes, commercial, you can see the numbers. There's about 5 million commercial buildings in the U.S. The U.S. annual building energy spend is $413 billion a year. Worldwide, $2 trillion a year is spent to heat, cool, and light our buildings. $2 trillion. Now I'm thinking, anyone should be able, almost anyone should be able to get a little smidgen of that $2 trillion and build a pretty decent company out of it. Because that's what we're talking about doing. Can I get myself into that energy spend line item and take a little bit out for the value that we deliver? That's all we've got to do. It's a very, very interesting premise. So that's how I want you to think about this. A lot of people think about this space as, well, how many new buildings are being built? In fact, before you walked in here, you're probably thinking, how much retrofit is there and how many built? Who cares? Who cares? This is what I care about. There's $2 trillion spent, and if I can make that $1 trillion, maybe I can keep a portion of the trillion I saved for ourselves. Really, really simple concept. So as Steve mentioned, Steve left. Yes, Steve was smart. He got out quickly. As Steve mentioned, I was named Entrepreneur of the Year in in 2009, early 2010 by Inc. magazine. This was an amazing honor, and I'll give you a little bit of background on this, some funny things. First of all, the first thing that happened, I didn't know. I got to tell you, they didn't tell me. They came and did a photo shoot, and there's photo shoots and this and that going on all the time. And then the magazine hit the newsstands, and someone called me from an airport and said, "You're staring at me." And I said, "Well, I'm at a conference. I'm obviously not there. You're confused." And they said, "No, you're on the cover of this magazine." And where I was, I had someone bring me some of the magazines. The first thing that happened was all of a sudden, women started emailing me and calling me that I had not heard from in 25 years. Now, I was pretty enthused about this because they said, "Wow, are you hot? We had no idea." But then I realized they meant only on the magazine cover, not actually in person, you see. They really liked what the Photoshop and this and that they did. So it was a really fun thing. So that was the first thing. It's all of a sudden the magazine cover looks a little better than life. And so you sort of really learn about these models and airbrushing and all that, because that's what they do. In fact, when they came in, they actually, like you'll see this is nice and thin here. It's because there's clips behind me that have clipped the clothes behind you. They're like big clothespins and things. It's really interesting. 5 years of startup insanity. Was it worth it? Now, I should point out that I didn't write any of these headlines. But people start calling me saying, "Well, was it worth it?" I didn't even read the article on page 102, let alone write it. I have no idea. It's hard, right? And, heck, you should micromanage. I guess sometimes you better do that when things are going bad. 10 rules for a happy entrepreneurial marriage. I do not know how to create a happy entrepreneurial marriage. Please do not ask me. I didn't write the article. I don't know who wrote the article, and I don't understand the article, okay? But the last but not least, the one that really sort of continued to get me was this: how to build a great company even the worst of all possible years. And everybody kept asking me, "Really, how do you build a great company in the worst of all possible years?" I said, "I don't know. I didn't write the headline. I have no clue." But that didn't work. You couldn't keep saying that. So I really had to start thinking about what we did build to the people reading this magazine and to others was really a great company in the worst of all possible years. Now, I don't necessarily see it in the same light, but that's what people out here saw. When you couldn't build a company, and you couldn't build in this space, and you couldn't grow, we were. So there were some things that we were doing, and that led to the thinking that I'm going to lay out here. So the first of the 9 things that sort of I thought of that maybe we did that might be useful was to identify a problem. And I do think that if you're going to build a decent company, you should identify a real problem. I have a rule that somewhat was, I think has been Apple's rule, is that customers don't design products, but they will tell you what the problem is. It's up to you to listen to their problem and then design a product or service to meet that problem. And that's really, really critical. There's an awful lot of companies in this valley, and certainly that I've worked with, that have this notion of, we're going to listen to the customers and they're going to tell us if they want blue or green. I'm making it up, colors to make it simple. No, they're not going to tell you that. What they're going to tell you is that they have a problem. For instance, a simple problem might be, I only want to carry one device, and I want my contacts on it, I want my email on it, I want my calendar on it, I want it to be my phone, okay, great, you've now described an iPhone. That's great. But they needed to say their problem set. And so you've really got to listen to customers' problems. So we wanted to identify a problem. Now, for us, the problem was a really big problem. The first thing is that there was an early industrial revolution, of which all industry is based, basically, that was arguably the 1700s and later 1800s, where energy was nearly free and CO2 was fine. That is, everything we built, created, whether it's buildings or materials, we created in an environment where we don't care about the cost of energy because it was nearly free. In fact, it was about 6 cents per million BTU at the turn of the century, the 1900s. And CO2, I don't know, it was just CO2. There's plenty there. It's all fine. That's what we thought. But the new industrial revolution, when you start thinking about what you need to do with all of your buildings and all of the things you build, is that energy is expensive and running out, at least traditional sources, and that CO2 is responsible for climate change. So if you make this assumption, you say there's some play between that and this, and that companies, buildings, people, homes have not made that transition, haven't even thought about how one would make that transition. Now, I think you'll enjoy this. I actually went and got the raw data from NASA and plotted it myself, because we've all seen these sorts of things. I encourage you to go get the raw data and plot this, because as you plot it, it really strikes you something has gone wrong here. It's one thing to look at other people's plots. It's another thing to put the data, in Excel and actually plot this. So I did, and there's, 1,000 pieces of data or whatever it is, and you can see somewhere around the Industrial Revolution, when it's really taking off, 1850 to 1900 or so, the thing shoots up. Now, it just doesn't take a genius to say something's gone wrong. It's probably not good. It was the same for about 1,000 years, and then it went way up there. Just something's not good about that. And this is a worldwide temperature data, 3-year average, again, plotted by me, and you can take different averages. You can do a 5-year average, you can do 2-year average, you can do no average, but this is what I did because I wanted to smooth the curve a little bit, and you sort of see what's happening from 1800 to now, and then there's some leveling and different things, and then it really starts to take off, and it's just really, really hard to argue that point. That's 1 degree Celsius. It's 100 basis points is what it is in Celsius. So then you look at the actual Arctic melt versus the IPCC model. So the IPCC, out in just a few years ago, and they said, here's all the models that we can put together. The nominal one, the average one is here, that the Arctic will melt somewhere around 2100, somewhere off this chart. It turns out, based on satellite data, it's going to somewhere around 2017 or 2018 or 2019, the Arctic will be fully melted at least for some period of weeks in the summer, probably in September. Well, this strikes me as a problem. It strikes me as a problem because the best scientists in the world said it'd be out here, but it's actually, even in the midst of doing this, we still said the models say this. And it turns out that our climate models, of course, are missing huge portions of data that we need, including what the feedback loops are and these sorts of things. We just don't understand. And when you talk to the climate scientists, they tell you, look, this is the best we could model. We don't actually believe it. It's going to happen a lot faster, but we had to fill in with real data. We couldn't take guesses, and that's what it comes up with. So this is all part of figuring out the problem. Greenland melt per year, the net loss, is crazy. I mean, that is the net loss. It's not arguable. Hopefully it won't all collapse, but if it did, the oceans rise 23 feet. That would be bad. And then if you just want to look at actual historical data and not models, you'd say, what happens to the ocean in feet at infinitum? So out, we don't know if it's 100 years or 1,000 years, but just, the steady state place is somewhere, in the good case, at 700 to 750 ppm of CO2, you end up with something like a couple hundred feet of ocean rise in time. Now, that's just historical data. This actual red line is an actual plot of historical data. The ocean has been there before, and it's been down here before. That data exists. We can go get that. So it's really, really interesting. So there is a problem, and there's a big problem. Well, if that's the problem, and we think that burning fossil fuels is the cause, we go, well, what are our energy supplies? Well, obviously, when I did this plot originally, and this is DOE data, EIJ data, and I actually thought that we'd see wind and solar be, 8% of the world's energy supply, or 12%, or 20%, I don't know. It's still less than 1%, and that's the problem. And the reason is that as much as we're doing wind and solar, what's happening is that we're continuing to use more and more fossil fuels as well, especially as China grows and India grows, et cetera. And so we're barely able to keep up on the renewable side. So that clearly, there's another problem there. So there's a slew of problems. We've already seen that, and we know that's where our usage is. And so what is the world doing about this today? Well, this is what it's doing. It's roughly going to build 6,000 coal plants over the next few decades. It's about 3 to 4 each week. There's 18 additional terawatts, and it goes, we're done. Let the buildings use it. We're taking people in China, for example, who used no electricity and no natural gas and virtually no energy at all, from the countryside, and sticking them in a city and giving them air conditioning. And, that's interesting to do to 1 or 2 people. It's not interesting to do to 1 billion people. It's a real serious issue. Yet we can't tell them not to do it. So this continues to be the cheapest way there. And the reason is that you can generate electricity from a coal plant, especially a coal plant that's been written off, for about 3 cents a kilowatt hour, 3 to 4 cents a kilowatt hour. It's really cheap. It's just very, very hard to beat this method. And when we talk about grid parity in solar, we really talk about grid parity at the retail level of 30 cents a kilowatt hour, 25 or 35 with government rebates, whatever the number. We don't even think about how one's going to get to 3 cents, because those numbers are crazy. So these are all continuing problems. Well, if there's a problem, that means there's opportunity. And when we looked at the opportunity, of course there's supply-side opportunities that have been well-funded, solar, wind, biofuel, and there's lots of companies out there doing an awful lot of work there. But we looked at the other side and said, in energy efficiency, there's engines and motors and hot water heaters and LED lights and appliances and smart grid and buildings and all kinds of things that one could do. almost an unlimited set of things. And so I thought it was interesting for quite a while that so many people were focused on the supply side and no one bothered with the demand side, but of course supply and demand ultimately get to equal out. So we want to work on the demand side. So we went to work on the demand side. And then we said, look, there's some choices of humanity that humanity can take. And you know, either we make an assumption that there's no climate change, but we act. Now, if there's no climate change and we act, we waste money, we invent new technology, and we reduce our reliance on oil. Actually, still not bad. We acted, but there was no climate change. Still not a bad outcome. Let's say there's no climate change and we do not act. Well, life goes on. Nothing wrong with that, okay? So as long as there's no climate change, we act, we don't act, fine. What happens if there is climate change? Well, if there is climate change, and it's really happening, and we act, we spend money, but we save 1 billion lives, invent new technology, reduce our reliance on oil, and create millions of jobs. Still a good outcome. So there's 3 quadrants here that are still good outcomes. But there's one quadrant that doesn't seem to be a good outcome. Because if there is climate change and we do not act, which is the 4th possibility, billions die, there's large wars, horrible famine and drought, end of the world as we know it, total economic collapse, and possible extinction. Now it would seem to me, I'm not a genius here, okay? It would seem to me this is an opportunity. Because this is bad, okay? These not perfect, this is good. So if you were going to do something, either act or don't act, and you were playing a lottery ticket, you certainly wouldn't play this line on them because you can't win. But you would play that line on them because either way, you do okay. So it's just another way to sort of think through the thoughts on this. So there's clearly a large problem set out there, if you want to define this problem set as large problem set, and probably a lot of things we can do. Now, for us, we had to design some products. That means you've got to really think about how you start to address those things. You've got to provide great solutions that solve real problems. One of our very first products was a product called QuietRock. Maybe many of you use it. It's very popular. We've shipped a couple million panels of this. QuietRock is 1 layer QuietRock equals 8 layers of regular drywall, or 6 layers, or 5 layers, or 4 layers, depending on the structure of the wall. And basically, it's soundproofing drywall, so it stops sound coming from one side to the other, and you save all that material and all that labor, so it ends up being cheaper and much more reliable. A great technology. It's based on a technology called constrained layer damping. We invented it back in the early 2000s, 2003, and it's really been a fantastic product. We've got Surace windows and glass that I'll get into later that are really complex and really much better. We listened to customers and developed a new technology called iWindow. We developed software that manages buildings like this just for energy efficiency on top of the building management system. So there's building management system, and then there's energy efficiency platform. So we can drive energy efficiency in buildings. But when you do these things, I can tell you, there's the old industry and there's me. They're going to yell at me, and they do. Because as you, in any of these industries, as you encroach in what they do, they're going, why are you here? What are you doing in my sandbox? This is really uninteresting. We don't like you here. Please leave. So you have to be ready for that. And when you're going to change an industry, especially an old industry that may not have seen any R&D in 150 years, you know, truly, I mean, get ready to get yelled at, and you will. And get ready to get letters written, and get ready to have people say, don't do this. And I'll give you some examples later. But maybe it's not those 2 things that make a great company. Maybe one of the ways to define a great company is a company that gets lots of awards. Because if you get awards, it means you're getting recognition by peers. And recognition by peers can be important. And we've had 7 or 8 years of award-winning products and lots of brand recognition and awards for the company in terms of tech company, et cetera, et cetera. So really, really wonderful awards. And so maybe you want that kind of recognition. Or maybe it's your people. Now, the thing with people is you've got to hire the right people for the job. Our very first VP of sales, I'm going to call him Ed. We'll call him the incredible Mr. Ed. Now, you see, he came from a little different era, and it wasn't really a huge success in that particular role.
Hello.
Just to remind you what it's like.
Mr. Ed.
All right, who remembers this show?
A horse is
That's
a
right.
horse, of course, and no one can talk to a horse.
Okay,
of
some
course.
of you are
That
singing
is,
with
of
the
course,
song. This
unless
is not
the
good.
horse is the famous
So-
Mr. Ed.
There's nothing wrong with Ed being the name of your VP of sales. There's something wrong if Ed happens to be acting like the horse. And this is a great example. I mean, here we were a tech company, and we brought in someone from the industry who had 35 years of industry experience. And the first clue was he didn't use email and didn't have a cell phone. Now, that's actually a really good clue that something's going to go wrong. So he goes to his first conference trade show, and, we have a booth or whatever it is, and I'm figuring, wow, there's no way to contact him, but there's going to be hundreds and hundreds of these dealers there, and we need to get these dealers. And he comes back. And I said, how'd it go? How many cars did you get? Probably got hundreds. We've got all these leads. He says, no, I just got one. I'm sorry, you were there 3 days and you got one card. I got one card. Tell me what's going on. Well, we have this QuietRock drywall, and it's like 4 or 5 times the price of regular drywall. And, people buy on price in this industry, and so unless it's about the same price as regular drywall, no one will buy it. I said, now hold it. This is ridiculous. It has 10 times the value of regular drywall. No, people buy on price. It looks the same as regular drywall, so no one's going to pay anything for it. What was my answer? You're fired. Thank you. Yeah, excellent, excellent, excellent. It's the one thing I learned from Trump, right? Once in a while, you have to just do that. And so it turned out that right after that, I got someone from the semiconductor industry who didn't know what drywall was. And within a month, I think we had 50 dealers. Why? Because she realized that the overall cost of a wall was $10 a square foot to make a wall of a certain, we'll say, soundproof category. And we could make one for $6. So why wouldn't a contractor save that $4 a square foot that he didn't realize he was spending? And nobody ever laid it out to him that way. So it was really a value and a solution sell. And you couldn't just go in and sell price. And so we're in an industry, in the built environment, where everything's been built on price. Why? Because everything is the same as it's been for decades. And so it just comes down to price. What's your price for that door versus his price for that door versus his price for that door? Not that one is better than the other. They're all the same. So when it came down to buying drywall, everybody bought one that was a penny cheaper than the other one. It came down to a penny. And so to now enter an industry and say, actually, I'm going to rethink this industry and show you something that adds 10 times the value of anything you ever had, took someone from a totally different industry who was comfortable in solution selling. And so you got to get the right people. But maybe it's not just that. Maybe to build a great company, you've got to have vision. And I think you do have to have vision. It's certainly part of what you do. And we had a vision of the future 5, 10, 20 years out on maybe what buildings would look like, how they could be constructed. These are just some examples of sort of some of the things out there. And some of these are a little crazy, and some of them are already built. That's a little crazy, but it gives you an idea of where things could go. But you have to have vision around products and where the whole industry could be and what the ultimate of what you could build could be. But maybe it's not that. Maybe if you want to build a great company, it's all about your customers. And maybe you have to have amazing reference clients because they really do help a lot. Now, here's just a few of the projects we've done. We've been in some 70,000 projects, which is sometimes about 69,000 more than most people think. That's all our glass there. This is a great project. I took this picture. I was just there a couple of months ago. That's the New York Stock Exchange. That's from the floor of the Stock Exchange. We redid all the glass, first time in about 5 decades, up above the Stock Exchange to a high R value. Does everyone know what this building is? Okay, does anyone know what this building is? Yes, excellent. The Empire State Building. The Empire State Building was built in 1931. 6,514 windows. There's a reason I know that, and 26,000 panes of glass. So we were contracted to replace every single window in the Empire State Building. And we wanted to change the dual pane windows that they had to a high R value technology. They already had dual pane. Let me say it again, they already had dual pane. Dual pane windows were invented in 1865. Probably didn't know that, did you? You thought it was 1965. No, it was 1865. And the high-speed process to make a dual pane window was patented in 1931, the same year the Empire State Building was built. It already had dual pane windows. State of the art, actually, when they put them in 1992, so to speak. Well, the dual pane window, it turns out when they put it in versus the single pane window, didn't save much energy at all, which is exactly what the models would say. Didn't really save much at all. Saved a little, not a lot. I know that's a surprise to you who have been buying dual pane windows. How many people have dual pane windows in their home? How many people have single pane windows in their home? How many people have something much better than a dual pane window in their home? Yes, I know you do. and you do. So we got 2 or 3 here that have high R-value windows or whatever. So what we did is we took all this glass out every night, and we built a production facility on the 5th floor. We took all the glass down to the 5th floor, took it all apart out of the spacers, cleaned it all, ran it through our equipment, built a new window out of it with a suspended film, a dual chamber, filled it with gas, sealed it up, and put it back in. And when people came in the morning, they had brand new windows that were 400% better than dual pane. 400%. It's never been done before. Now this was, nobody's ever reused glass before. This was an integrated design approach with a lot of partners. Johnson Controls, Joan Lang LaSalle, the owner of the Empire State Building, Clinton Climate Initiative, Rocky Mountain Institute. And the idea here was if we could really look at all of the components of some 60 different retrofit measures and pick 6 to 8 of those. If you pick the right 6 to 8, you could do something that's never been done before. Instead of replace all 3 chillers, you'd only replace 2. So you could subtract one $17 million chiller plant right up front. And if you did that, you'd get a payback in less than 3 years. And that's what we did. Very unique design approach, very unique way to address this. Now, the most important thing about that glass thing that I just told you about reusing the glass, and here's some of our people, you'll see them removing windows and working on the windows and working in the production facility. The most interesting thing about saying you want to reuse the glass is that if you make float glass, that is, you melt sand and make glass, if that's what you do as a company, you don't want Surace Energy showing that you can reuse the glass in the Empire State Building. It's just not going to be good for business. Now, how much energy does it take to melt sand? Well, I'm going to give you a little experiment. Please go to the beach this weekend. Get some sand. Put in a kettle on the stove and turn the stove on high. Leave it there for 24 hours. The kettle will melt before the sand does, I assure you. Okay? This is not an experiment you should try at home. The net result is that people, other companies who make float glass, did not like the fact we told the world you could reuse glass. And so they wrote nasty letters to the owners of the Empire State Building and everybody else saying, you can't reuse the glass, the building will fall down. I'm being a little facetious. They didn't say the building would fall down, but for a fact, I'm going to say the building would fall down. Clearly, the building didn't fall down. Nothing happened. You can reuse glass. It is absolutely possible to do. It probably doesn't make financial sense to do so in your home, but in a large structure or a large campus, it absolutely can make sense to reuse the glass. No question. 6,514 windows, 26,000 panes of glass. We reused it all on site, saving $410,000 a year in energy costs. The payback was 3 years, $28 million over the life of the windows, 50,000 tons of CO2. The energy savings equivalent of $5 million of solar panels, of which there's no room on the Empire State Building to place. It's a good project. That's a great example of a great customer. This is a couple of years ago. But it gives you an idea of when you have those big customers, how important they might be to take your business forward. Now, I want to talk about disruptive innovation because that's one of the things we think that we have to bring to the party. Disruptive innovation is very, very critical. And with disruptive innovation, you can't be afraid. You know, my friend Brene Brown studies shame and topics around that by questioning now thousands of students down in Texas. And, you know, one of the things that happens in disruptive innovation is risk. Because regular innovation, humans don't have to take a lot of risk. We'll just innovate a little. But if you want to innovate a lot, you're going to take a lot of risk. You're going to risk the company, and you're going to risk your personal reputation, and you'll probably fail much of the time. It's very scary to be disruptively innovative, which is why very few companies can be disruptively innovative. There are some examples. There's the best example I can think of all time, without question. He was so disruptively innovative that they asked him to leave the first time for being too disruptive and too innovative. However, when he came back, he sort of had carte blanche. So it's a very unique situation where someone actually was sort of given carte blanche on the way back. The company was nearly bankrupt. Now here's a company that's nearly bankrupt, and in short order he goes to the board and he says, you know what, I know we're a computer company, but instead of really, really worrying just about that, we're going to become a music company. We're going to be the 50th music player on the market. And we're going to dominate that, and we're going to grow that into an iPod Touch, and eventually the iPhone, and then eventually the iPad. And it turns out each one was disruptively innovative to entire categories of products. entire categories. But you had a unique situation in Apple where the CEO could literally mandate that and had a mandate from the board to say, look, do what you got to do. And he had the fellowship of the people to do it. It's a unique and rare situation when you have that. It's part of what makes startups really good, because you've got a CEO with a vision, and at least for the first few years, people will just follow that, and they all sit around, and the vision and the concept comes up in a bar somewhere, and it's on a napkin, and it's very disruptively innovative. But when you get bigger, it's really hard to do. So let's take an example of a tissue company. Doesn't matter which tissue company. But let's say there's a tissue company. I'm going to give you an example of typical innovation at a tissue company. Now, someone at some audience somewhere is going to be working for a tissue company and yell at me that I've used this example, but I'm going to use the example. So here's a tissue company, and of course, what do? They get they want to come out with a new product. They want to come out with a really innovative product. So what do? They bring product marketing, they bring sales, they apparently bring the US Army in. I don't know, it's a stock photo, right? So they bring a whole bunch of people around to think about what they need to do with their product and how they can make their product innovative and disruptive and really, and after a year of research and thinking and talking to manufacturing and testing the plant and all these different things, they start with that tissue that they had before, and you know what? They're going to be really disruptive this time. And they bring it into the CEO's office and say, boy, are we going to disrupt the market, because we're going to take this beautiful white tissue and we are going to make pink tissue. Now I'm thinking, innovative maybe, disruptive probably not. There is no market the pink tissue will disrupt. But this is quite typical of what happens in not only corporate America, but corporate worldwide. Now, why does this happen? It's because everyone around that table, every single one, is scared about standing up and going, excuse me, we're not actually in the tissue business. I know we have plants that take wood and chop it up and get pulp and put water in and boil it and do all the things, whatever kind of process it takes to make a tissue, which cannot be easy, by the way, when you think about how thin a tissue is. But nevertheless, they do that. And they think that's the business they're in. That's not the business they're in. That's not the business their customers see them in. The business the tissue company in is one of cleaning the nose. That's the actual business they're in. So someone would have to stand up and say, excuse me, we're not in the business of tissues. We're in the business of cleaning the nose. And since we're in the business of cleaning the nose, maybe we have to think outside the box and not think about making more tissues or making pink tissues or blue tissues. But instead, maybe what we need to do is make a machine. And it's called the snot sucker. And you see, now you've got this big thing. You see, I didn't go to MIT, obviously. I've designed this out of whatever parts I could find on the web. And see, there's the nose, and there's the suction device. Okay, now we've got it. Now, you can clap for that, thank you. I worked on this artwork really, really hard. Now, the point is nobody's going to, well, okay, one of you might actually go build this and probably make a mint, but please give me a few percent of it. The point is no one would really build this. The point of this demonstration is that you really want to think outside the box about what problem you're solving for your customers. The problem you're solving for your customers is to clear their nose. The only reason you think you're in the tissue business is because you have plants that make tissues, and that's what you've done for 200 years. But you're not in the tissue business. You're in the business of cleaning their nose, and that's all they want is their nose to be clean. So whether it's a machine or it's a tissue or something else, that's the direction. Now, why don't people stand up and do that? Well, because they're afraid that they're going to get ridiculed from across the table. It's risky. It's human nature to not take that risk. They're afraid they're going to get ridiculed from the leader of the team. They're afraid that the leader of the team is going to go tell their boss. They're afraid that's going to get the CEO. They're afraid they're going to get fired. Can you imagine being in a tissue company and me walking in saying, I've got this great idea. How long would I still be at the tissue company if I put that up on the slide? They'd think I was nuts. And so you have to be able to take huge risk to be disruptively innovative. You know, before the iPad first came out, Apple had to take a risk and build a couple million of them. Didn't know if they'd sell any. Built a couple million. Of course, they sold out in a day or whatever it was. That was a risk. It was a huge risk. To be the first computer company to build a phone. I don't know if you remember. I mean, the iPhone, that was ridiculous. A phone coming from a computer company? Today we think, of course phones come from computer companies, especially Apple. But at that time, phones came from Ericsson and Sony and Nokia and Samsung and whoever, Motorola, etc. Now all of a sudden a phone came from a computer company. Highly risky, highly risky. With risk comes reward, and with risk comes disruptive innovation. So you've got to encourage your teams to take that kind of risk and not be afraid of taking absolute personal risk. Absolute personal risk. And in some cases, even risking the company at times. So, obviously we've taken our risk and we think we've been very disruptively innovative. One of the things with windows is heat goes out the window, by the way. In fact, virtually in every building, all the heat goes out the window. In the summer, all the heat comes in the window. It shouldn't be a surprise. The reason is your walls are much better than your glass. Most people don't know that we've improved our walls, for instance, in our homes, dramatically over the last 20 to 30 years. The R value, or the resistance to heat flow, has gone up. So, of course, we regularly build walls that are far better than R10, R11, R12, R13 now as an entire structure. So we build really pretty good walls. Look at our window. You didn't know this is what's happening to glass. In fact, dual pane low E is about R3. Compared to the walls, they stink. Well, that's why all the heat goes out the window, because it's going to go in the path of least resistance, and that's exactly what happens. So you've got these windows and the glass systems that are far not as good as your walls, and that's the net result of what's happening. That's usually a surprise to people. So when you want to address windows, we looked at addressing windows. We said we're going to make product that's 2 times, 3 times, sometimes 4 times better performing than the major brands. This is just a really nice chart. R0 is an open hole. This is a very important thing, by the way, right? So on the R chart, R0 is an open hole. There's no resistance to heat flow. R1 is a single pane window, way down here. It's almost R0. In fact, it's closer to R0 than it is your wall, which is up there. Your wall is around here. It's down here. There's hardly any difference between R1 and R0. They're not particularly good. R2 is dual pane. It's still closer to R0. R2.8 was the old Energy Star. R3.3 is the new Energy Star. We focus on windows and glass systems that are up in this range because that's much closer to your wall. And it turns out when you do that, not only do you save energy, but you're more comfortable because now you can sit next to the window in the winter and it's no colder than sitting next to the wall. And you can sit next to your window in the summer and it's no hotter than sitting next to the wall. In fact, it looks like a wall, except you can see through it. It acts like a wall. It gives you the comfort of the wall. And when we make people more comfortable, what happens? In a work environment, they're more productive. And doesn't that start to address that right end of the scale that we talked about earlier of the $400 or $300 to $3,000 a square foot? Again, you see these charts. This is the average U.S. home saving versus single pane, and you can see if you're getting high R value windows, you're going to save a lot more than stuff down there. This is HVAC savings in commercial, depending on the window to wall ratio, and what the savings is in high R value versus dual pane versus dual pane low E, and high R value, and what you can save. This is a great product called iWindow. We called it iWindow because Apple hadn't gotten the trademark for iWindow. They just hadn't thought of that, so we thought we'd do that. Actually, it means sort of interior retrofit window. Now, the interesting thing about this is we listened to customers on this. Now, customers didn't say, I want an iWindow. Let me tell you what iWindow is. iWindow is an interior window that fits on the inside of a high-rise window and creates a new window out of the old window without removing the old glass, taking it from R1 to R7. Did you follow that? A lot of words in just a very short period of time. Now, why is that interesting? In fact, it's not obvious that anyone would want to do this. Why would they want to do it? Let me tell you why. Because if you're in New York City and you want to replace your outside glass with new high R value glass, the labor alone for the glazers is about $100 per square foot. Now, at $100 per square foot, if I made my glass $0, the payback would still be like 30 years. Now, I could not figure out how we could make our glass less than $0. We looked at it, thought about it, put our best people on it, and 32 seconds later they said, Kevin, you're being ridiculous. We can't make glass for negative $18 a square foot. So clearly that wasn't the way we're going to solve this. So then we said, well, what could we do? Well, what would happen if it wasn't glass anymore, if it was pre-framed? So it wasn't a glazer problem, because glazers handle glass. So let's say it wasn't glass. It was a pre-framed system that wasn't really installed, but instead it was more like a maintenance procedure. It's a temporary installation where you can put it in with 4 screws and it comes right back out. So it's a maintenance install. Well, if you could use your maintenance people, if you could do this, you could install it for $2 a square foot instead of $100. $2 a square foot of labor. And it would take 15 or 20 minutes to install each one with one guy. So it's really, really easy, it's fast, it's cheap. Now, what was the customer problem here? The customer problem was, I need a 3 or 4 or 5 year payback. The customer didn't say, I want an iWindow. He said, I need a 5-year payback. We listened to that and said, how do we get a 5-year payback on anything we can do in glass? And it turns out the eye window was the invention that did that. And this can be bought for $20 or $22 or $23 a square foot all up, including installation, instead of, call it, $120 a square foot, what it used to be before. And that's what gets your payback down to 3 or 4 or 5 years, or 6 years, in that range, in many buildings. So it gives you a great idea, a great example of how you listen to customers and turn that into a product that they could have never thought of. There's no customer in the world who would have thought of this. But boy, they knew what their problem was. The install retrofit cost, you can see what happens from just very simple fiberglass windows, commercial glass, et cetera. Depends on where you are in the country. We happen to make some really advanced fiberglass components as well, so the most advanced fiberglass in the world. We've actually built the world's first fiberglass curtain wall. All of the vertical columns and horizontal columns in this building that hold all that glass in is fiberglass. It's not aluminum. That's the first building in the world that's all fiberglass. We built it. We didn't build the building, we built all those components. Why is that important? Fiberglass has, probably 10 to 100 times the R value that aluminum does. If you wanted to get something that has great thermal conductivity between the outside and the inside, aluminum would be the thing you'd pick. Okay? We don't want thermal conductivity between the outside and the inside of a building. Why did we pick aluminum? Well, you go back to the 60s, and either it was the only thing available, or those particular companies got designed into all the code and the specs, which happens to be the case. Can't blame them. It was 60s. That's what they made. They made aluminum. They're in the spec. In fact, they're in the specs so much that in the United States, you can't build one of these. Why? Because aluminum is literally called out in the spec. You must use aluminum. So, excuse me, not in the spec, in the code. You actually have to go change the code. So you have to sit in front of a city council and say, hey, we got to change the code to fiberglass. And, oh my God, the building might fall. No, the building's not going to fall, but the aluminum guy says the building will fall. So now you got to show them that the building isn't going to fall. It's the same thing we dealt with glass. We came out with Surace Energy Manager. Surace Energy Manager does manage buildings through algorithms instead of people. A building management system is a great system. They've been around for a long time. That's where people put in set points and put in times, and things come on and off to what the people said. This looks at the weather forecast, it looks at the weather, looks at the building occupancy, uses algorithms and analytics to say across all your buildings we're going to drive energy savings in ways that you could never think of. We see in every building heaters and air conditioners running at the same time. Who would allow that? By the way, every BMS allows you to do it because you can put anything in you want. This says, excuse me, can't run heaters and air conditioners at the same time. The only one who's going to win is the utility company because they're just going to battle each other. And we're seeing savings of 10, 20, 30%. 10, 20, 30% in each building. We even went into a LEED Platinum building. LEED Platinum, everyone knows what LEED is probably. LEED Platinum is the best there is. We went into a LEED Platinum building, saved 13%. Over what the top energy people could get out of that building, the software saved another 13%, made the building more comfortable. Talk about some future things that are being worked on. Cirrus Transitions is a low-cost dynamic liquid crystal glass system. Instead of building electrochromic and electrochromic factories, of which there's 2 being built in this country for almost $100 million apiece, we said, why wouldn't we use the liquid crystal display technology that already exists? So we've got a slew of patents in this area to make liquid crystal, basically liquid crystal windows. And it turns out that would have made no sense just a few years ago because LCD was very expensive. But today, every time, how many people have an LCD TV? A lot of people have an LCD TV. Thank you, that lowered the cost of our windows. Okay, now you get the point. Everyone who's bought an LCD TV has continued to drive down the cost of this next generation dynamic glass. So rather than build a custom electrochromic dynamic glass factory, we're going to be able to produce liquid crystal-based transitions, products that switch 500 times faster than electrochromic, and they're half the price, leveraging existing infrastructure. Next generation beyond that is something we call Adaptive E. This is an ultra-low-cost, wavelength tunable dynamic glass. A lot of words for one sentence. It's thermally switchable. This is a high-speed, multi-layer thin film process on PET. It's actually 100 layers of thin film in a Bragg filter design, so about 50-layer pairs of Bragg filters. Won't get into all the technology. I just tell you that for those who want to follow that. This approaches the cost of dual-pane windows. It's that cheap. It's really, really cheap. We're running 6-foot wide film, 500 feet a minute, 5,000-foot rolls. That's what we're going to be able to do with this. Truly next generation. So there's some of the innovation. I think the biggest innovation that we've had is Cirrus Solutions. There's no words on this slide, just some pictures of buildings. For all our patents and for all our technology and for everything that we've done, what we kept hearing from customers is, that's great, but I don't have any money. Or I do have money, but I'm not going to spend it on fixing my buildings. I've got bigger things to do. Well, if the objection continues to be, I don't have the capital to put into this, it's a serious issue. Because all of the engineering in the world, the technology engineering, won't solve that. I could have 1,000 patents, and I'm still not going to sell any more than I sell today. So what do I do? So we took the last 3 years and engineered a brand new financial instrument. And what we did is listen to customers again. And customers said, listen, I could go out and get a loan against my building, but my building's underwater, so I guess I can't. Well, that won't work. So that means the mortgage is off the table. Or I could go out and do a lien against my taxes, except, you know, Fannie Mae, Freddie Mac on the residential side and the banks on the commercial side won't let me do that because it changes the balance and who's in line and all of that. Okay, so that's out. So you go, what are we going to put a lien against? Well, I mean, if we were to supply the capital and we were to do all the upgrades and really make the building worth more, and we were to do that all for free, what would be in it for us? And so we invented a brand new financial instrument. And what we did is we securitized only one thing: your future 20 years of energy payments. That's it. I know you're going to pay them. In fact, you'll pay that before you pay the mortgage, because if you don't, power company shows up and turns it off. So we like this. It turns out you can, in theory, securitize future energy payments. Now, this is rarely done. In fact, future payments on anything is rarely done. There's a few musicians that actually, because they needed money, securitized their future royalty stream, because you could calculate the future royalty stream and put some discount on it, et cetera. So why not calculate the future energy payments and put a discount on that, and we'll actually securitize that. And then we become the power agent. So in fact, we will come in, upgrade your building with new lighting, lighting control, Surace Energy Manager, software, all iWindow, HVAC upgrades, et cetera. We'll do it all for free. We'll give you some of the savings, and we'll keep some of the savings. And for the savings that we keep, we pay for those upgrades over 20 years. You don't pay a dime. Now, what did you get? You got an upgraded building. You hit all your sustainability goals. You got a building that's worth more. You got people that are more productive and more comfortable. And I'm going to give you a check every month that you didn't have last month. Every month, free cash flow. I'm going to take this underperforming property and give you free cash flow out of it. And by the way, you don't pay me a dime, ever. Just keep paying your utility bill. I'll sort it all out. Discounts, rebates, this and that, we'll sort it out. And it's not your core expertise anyway. Now, by the way, this is completely disruptive to the efficiency industry, and we just launched this in December. It's totally disruptive. I cannot think of something more disruptive. As cool as all those technologies were, there's nothing cooler than this. It's just nothing cooler. It's brilliant financial engineering. And this came out of customers, again, telling us their problem. They didn't have a solution. They just said, I have no money, and you can't touch my mortgage, and you can't touch my taxes. Please leave. Well, I didn't like the please leave part. So that's when we went to work on this. And it's truly a brilliant piece of financial engineering. And we think it changes the entire scope of the industry. 5 million commercial buildings, all of a few thousand, a few tens of thousands have been upgraded over 30 years. So look at the opportunity just in the US. And there's about 20 million commercial buildings worldwide. Now, maybe it's not just those disruptive products, maybe it's disruptive marketing. And we talk about owning the conversation. I'm only going to put one slide up here, and I think this is really important because marketing has changed dramatically in the last 5 to 10 years. We actually tracked for several years what our lead source conversion was. Here's direct mail. It's down in the gutter. Print advertising, trade shows, press, web. What does that tell you? Forget everything else. It's all about the web. Why? When people, whether it's a building owner or a homeowner, say, I'm making it up, I think I want new windows, or I want to save energy, or something like that, that's the moment of truth that you can grab them. It's the moment that you can grab them. And they're the most vulnerable to do the research to figure out what they want. I mean, that's the time you want them. And in fact, the idea of building brands is gone. There are some examples, of course, of excellent brands that have built brands and have built what we call affinity brands like Apple. But the idea of GE saying, for 10 years to you on a TV commercial, buy GE refrigerators. They're really good. Buy GE refrigerators. That can be undone in 1 second with someone going to the web and reading 20 reports of refrigerators that failed. Whether it's GE or Westinghouse or Kenmore or any brand, doesn't matter. It can be undone. A billion-dollar brand can be undone with one person on the web saying negative things. Or it can be a brand new brand can be reinvigorated or invigorated by 20 people saying good things. It's really, really interesting. The power of this is unbelievable. We have certainly used this without question, and we tracked it, and that's what was the most important. It really works. We absolutely tracked it. Now, maybe it's to do what's right, and we did a lot of what's right at a time when it was important in this country. People do take notice when you care. We rescued a plant in Chicago. We rescued several plants, but I like this particular story, and I'm going to flow through it real quickly. There's a plant called Republic Windows, and unfortunately, there was a little problem. The owner stole all the equipment and brought it to a brand new facility and fired everybody and put it in a little place called Echo Windows in a different state that was too far away to employ the union. The union realized that he stole it. By the way, the banks owned the equipment, so you couldn't do that. So the owner announces a closing and gives them no severance. Not legal. The union does a sit-in, the first time in this country in many decades that there was a sit-in in the plant, and the sit-in started December 5th, 2008. That's me. I went out and visited the plant, and you know, here's the workers, and they're all doing their sit-in, and lots of people showed up. This is a familiar ex-governor face that's unfortunately probably going to jail. He did not steal the equipment. He's there. Everybody shows up because everybody wants the TV cameras, right? He said, this is Armando's kid. He says, don't close our plant. So Bank of America was the lien holder on all that equipment, and in fact, even though they did a bailout they got the bailout, they did not want to hand over any severance to the workers. So Ken Lewis said, no, 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 and of course he's out too. And eventually on December 11th, 2008, Bank of America did agree to pay their 60 days of severance. And that was a big give, and it was the right thing to do. The workers obviously were very happy that they got their severance. However, there was some sadness because now the plant was empty, and it was closing. They lost their job. They got their severance, but they lost their job. So I found the oldest phone in human history and called on December 17th. Apparently I called Chris. I did call the union. That's a stock photo from the web. Obviously, it was the simplest thing I could drop in there. I called the union. It was very, very interesting. I called the union. I did not call Bank of America. I didn't call the bankruptcy guy. I called the union and said, how would you like it if we gave it a run, came out, and bought that plant and partnered with you and tried to bring you guys back and do the best we could. We went out and looked at the plant, and there was great equipment, and everything was there. And so there was a first deadline. The first deadline said we were going to pay several $1 million, and Bank of America said no. And we said, but that's good. Our deadline's going to hit on Thursday night at 5 o'clock. So the deadline hits, we send a new offer, and it says we'll pay you $2 million instead of 5, I think were the numbers. And B of A calls right away and says, well, what happened to the 5? I said, well, the deadline passed. You lose. Now it's 2. Well, we want the 5. No, now it's 2. You got 24 hours to accept that. Friday at 5 o'clock, that deadline passes, and we send them a goodbye letter. And they go, what are you doing? How about the 2? I said, no, it's gone. So then we struck a new deal. And the new deal was fairly interesting. It turns out during this time, we found out that someone had a lien on all the equipment. So we went and took over the lien on the equipment, which was all of $900,000. Once we did that, all the equipment was in there. It would have cost more to move it. And then we called Bank of America and told them that we now had the equipment and to please get out of our place. And so they didn't like that. And instead of getting the millions of dollars they could have gotten, the B of A ended up, I think, with $112,000. So it didn't work as well. GE had the lien on the equipment. They were nice enough to work with us. So we went in, bought the place, brought all the workers back, or brought some of the workers back. The vice president came out to visit. A book was written on this by Carrie Liderson called Revolt on Goose Island. Michael Moore came out to visit. He featured the thing, and he shows up everywhere. He's a big guy, by the way. This is the old owner, Richard Gelmy. He went to jail on September 9th, 2009, which I thought was a fitting end. Of course, I had to endure the lovely vice president and all his jokes for several hours. But aside from that, it was really, actually they were good jokes. It was really, really an amazing example of at a time when nobody wanted to buy a plant and nobody wanted to try this stuff, that we were willing to go out and do that. And in fact, at a time you could do it for 10 cents on the dollar, 3 cents on the dollar, 4 cents on the dollar. It was a great time to do it, and it was a great time to get recognized for doing it. Now, it remains to be seen whether every plant we got, of which we've got 6 plants, whether every plant we've got was the right place and the right time and the right this and the right that. But at that moment in time, it was the right thing to do for this country and the right thing to do for those workers. Obviously, we've had many other visitors. Everybody comes in. We won't talk about him anymore. Now, there's our 6 manufacturing facilities, and I'm going to play you just a very short video of us taking over a few plants that in the country at the moment that we did it. This only runs about a minute.
Surace Materials just reopened a manufacturing plant outside of Pittsburgh. Last year, that factory was shuttered. More than 100 jobs were lost. The town was devastated. Today, that factory is whirring back to life, and Surace Materials is rehiring the folks who lost their jobs. And these workers will now have a new mission, producing some of the most energy-efficient windows in the world.
It's a little town in Pennsylvania, factory in Vandergrift, Pennsylvania.
Green jobs are the jobs of the future, not just because they pay well and can't be outsourced, and not just because they help strengthen our economy and lift up our middle class, but because they help us reduce our dependence on foreign oil and may just save this planet for our children.
Republic shut its doors very suddenly early last month, but the 300 or so workers at the plant refused to leave the factory. Get this, a deal for a California company to buy the former Republic Windows and Doors company.
Tax credits are encouraging homeowners to make their homes more energy efficient. The single greatest immediate impact on the environment that we can have as a nation and the world can have is weatherization. That's the immediate biggest bang for the buck. You're not just churning out windows. You're making some of the most energy efficient windows in the world. I would argue the most energy efficient windows in the world.
You know, 6 months ago, this plant shut down, putting 150 people out of work in this town. I know it was a tremendous body blow for Vandergrift to see a cornerstone of this community close up shop. But today, we start rebuilding. Today, we write a new beginning to this story.
This is more than just a job to me. It's also doing our small part in this tiny corner of America to move this country forward.
It is time to fight back, and it is time for hope. And one of the reasons that I came here today is not only because it's such a great announcement, not only because Surace is such a good visionary company, but because there's good news. And amidst all the bad news, there is good news out there. And it's up to us as leaders, it's up to us as citizens to take that good news and run with it.
Anybody need some energy efficient windows? Union made in the USA?
There's a little review from 2009. So, you know, the net result of all of this for me, and these are my two children several years ago, they're older now, is to not be afraid to change everything we know. And I think we have to change a lot of what we know. We have to change the way we make product. We have to change the way we use product. We have to change the way we operate our buildings and we operate our homes. And we really have to think about the impact that all of this energy usage has had on the environment, especially fossil fuel usage. When my kids, and I've told them this, you know, it's one thing when I was younger, I had actually no clue about climate change or CO2 or anything else. It's carbon, I thought it was up there, and of course later I learned that, you know, this carbon that shouldn't be in the atmosphere, it should be in the ground and it should stay in the ground. You know, God put it there, or someone put it there, or whoever put it there, and it's supposed to stay there. In fact, it's not poison when it's in the ground, it's only poison when we burn it and put it in the atmosphere. That's the problem. And we need to leave it where it was supposed to be put. And so when my kids, and I call this the rule of 2050, but I think it applies to most of us. You know, in 2050, I do want my kids to look back, who will be much older then than they are now, and say, you know, I can't say Dad did everything right when he was 15. I assure you I didn't. But I do think that when he found out and he realized that technology could provide real answers and real impact on the environment and real impact to people's lives, he did the best he could with the knowledge that he had, and he built great teams, and they did the best they could. So I think that rule of 2050 is always a real good, salient way for us to consider what we're doing in life, because how are our kids and our grandkids really going to view us and what we did with our lives? So with that, now comes the only question that I'll directly have. I think we'll have a few minutes for Q&A after this. This is multiple choice. Out of all of the things that we did, I said the 9, which one do you think was the most important for building a great company? Was it A, identify the problem, or was it products, or winning awards, or people, or vision, or customers, or disruptive innovation, or marketing, or doing what's right? What do you think? Someone yell out an answer. F. Customers. J, A, G. Okay. All of the above? Okay, all of the above. All right. How many think it's all of the above? How many think it's one of those things? Okay, all right, a little bit of a split here. Well, I'll give you the answer. It's none of the above, but thank you for your time. I really, really honestly, you're not going to let me are you going to let me get away with that? No, you can't end that way. There has to be an end. So actually, we've thought about this, and of course, all of those are truly important. I mean, I don't think you build a great company without some of those happening or wanting to happen or listening to customers or all of the other things. But it all boiled down to us that in all of those areas, you had to do something else. You had to do something else that doesn't normally show up in that list. And for us, I think that's inspiration. It's not motivation, it's inspiration. It's how we inspire our customers so that they do tell us their problems. It's how we inspire our workers so that they want to show up every day and make the best products or invent the best products that they can. It's how we keep our family inspired while we're working this hard at these kinds of things. And I really, really encourage you to inspire the people around you to make a difference in some of the problems that we have in this country and in this world. So I hope I gave